In this part, we are going to dive into how bacnet mstp is put into action in the 1.4 version of the NanoEdge engine, and we are gonna start with client-server implementation. Being a bacnet mstp client means getting information from other bacnet devices on RS-485 bus. For example, Rack18 can act as a client and get setpoint and temperature data from TP wall module. On the other hand, Rack18 can also act as a server. It can expose the data on the bacnet mstp RS-485 bus, so the other devices, like for example Mac36, can get it. Bacnet mstp server configuration is really easy. As a default, all data points are shared on the bacnet through bacnet extension. All you need to do is to take care on which interface it's going to be exposed. As a default, we only have Ethernet interface. Let's drag then and drop serial port from the core library onto the interfaces. Then make sure that it's enabled and has correct communication settings. For the test, as usual, let's go into the Niagara, go to the bacnet network, select appropriate network number and discover devices on the bacnet network. Drag Rack18 onto the database. Go to the points folder and click discover again. All the points that have the exposed slot set to true are available here. Let's drag them to the database as well, change booleans to be writable over the bacnet and click OK. After a few moments, we should see all of them synchronized and operational. For the client configuration, we need serial port configured as well, but that's already done. So we need to go to the network. On the object properties, change the interface to serial port. Now we can go and add a new device. This is TP wall module. Select correct bacnet device ID and enable it. Go to the device's point manager view and drop analog point onto the view. Name it setPoint and click OK. To get the setpoint, I need to set object ID to 56 and voila, I have correct reading of the point. But that's not all. There is a new mechanism which allows you to read additional properties of the bacnet object, giving you more context about the data. By invoking read other properties action, you also read units and object name properties of the integrated bacnet object. Another addition to the network point is mode selector. In 1.2 we only had value mode, but now we also have input and output as well. If we take a look into TP documentation, we have plenty of value objects. But that's not the whole picture. To access more objects, we also need inputs as well as outputs. Let's read an analog input free then. Drag and drop analog input. Let's name it effective setpoint. In the object properties, set the mode to input and object ID to free. You get the reading of the value. Additionally, you can invoke read other properties action to get additional properties of the object. Usually when you read bacnet object, for example analog input, you read its present value property. But bacnet object is much more complex, and sometimes you may want to use other properties as well. That's what the custom points are for. Let's take a look into the documentation. We have analog value 56, which is a standard present value. But analog value 56 also has low limit and high limit properties. Now let's use custom points to read those properties as well. Let's drag and drop analog custom point onto the point manager view and name it low limit. In the object properties, set the object ID to 56. Select object type as analog value and filter the properties to get the low limit property. As an effect, you should see low limit value. Let's duplicate the low limit property and name it high limit. In the object properties, change only the property to high limit this time. And we get the high limit as well. There are also string properties, so let's read one of those. Let's take string custom point and name it object name. In the object properties, set object ID to 56, object type to analog value and choose the object name property. As a result, we have object name in our string custom point.